Good morning, everyone. My name is Renan Marujo, and today I'll be presenting the work evaluating the impact of LaSRC and Sen2cor atmospheric correction algorithms on Landsat 8 OLI and Sentinel-2 MSI data over aeronet stations in Brazilian territory. So this work was developed on the context of the Brazil Data Cube project, which aims to provide medium spatial resolution data cubes for the Brazilian territory. And this involves generating data cubes that use Landsat, Sentinel, ISPRS and several other sensors images. This project is hosted by IMP, which is the Brazilian National Institute for Space Research. And based on that, it is always important for us to see if those atmospheric correction algorithms are performing correctly. So this paper was heavily inspired on Doxani et al. Paper called Atmospheric Correction Intercomparison Exercise, which have compared several atmospheric correction algorithms on different images in different sites over the world. Based on that, this paper presents the results of a validation of the Landsat 8 OLI and Sentinel-2 MSI atmospherically corrected data using LaSRC and Sen2cor. And in order to do that, we have used mainly three measures: accuracy, precision, and uncertainty, as performed by Doxani et al. So first, we needed to generate our reference, which would be used to compare the generated products. In order to do that, we have searched for the aeronet stations over the Brazil and decided to use 5 stations distributed on the country area. And with that, we have acquired a few more than 400 Landsat and Sentinel-2 images. And to select those images, we have chosen aeronet measurements, which were done between 10 a.m. and 11 a.m., which are the time close to the satellite passage over the sites, and with areas of at least 16 by 16 kilometers in order to have enough area to compare data. So the first step was to interpolate the aeronet data to 550 nanometers, and alongside with the angstrom coefficient, which is also provided with the aeronet data, we have used both those data as input in the ArcSea software to generate a surface reflectance reference that would be compared to the generated surface reflectance products. So we start by generating Landsat 8 OLI surface reflectance using the LaSRC code, which is also used by USGS, the original provider of the data. So this data is equal to the already processed and distributed by USGS. And the LaSRC code can also be applied to the Sentinel-2 MSI images. So we have also generated the surface reflectance of Sentinel-2 MSI using the LaSRC, and also using the Sen2cor, which is the original atmospheric correction used by ESA. And having these three products, we compared the generated products with the reference surface reflectance, comparing mainly the APU metrics. But before we could compare these products, we have a few points that are relevant before this comparison. So Landsat 8 was used the collection 1 data because the collection 2 LaSRC code isn't available yet for users to process those images locally. The Sen2cor have been disabled the illumination correction in order for the comparison with LaSRC to be fair, since LaSRC doesn't implement this correction. We must also mention that ArcSea and LaSRC both use the same atmosphere correction model, which is the 6S, and that is different from the Sen2cor AT-core. And at least we must consider that only pixels that weren't masked as cloud, cloud shadow, or snow by fmask version 4.2 were used to compare these images. Here is the first plot on the Landsat 8 LaSRC comparison. And we can see these three lines, APU, accuracy, precision, and uncertainty, and a pink line, which is our suggested specs, which is our reference line. So the main idea of this plot is that the APU lines should be beneath this referential line. So for the coastal and blue bands, we can see that most of the data is above this reference line. And this greater uncertainty was expected since the coastal and blue bands are more affected by the atmospheric components than other bands. And this could be seen in here in band 3 and 7, which stands for the green band, and sphere 2, which we can see that most of the data is beneath this reference line, with a few more points with least data going above it. And we can see in the other spectral bands that almost all of the data, the APU metrics, were beneath this referential line. However, when we compared the Sentinel data, this did not occur. So here in the left, we can see the blue and the red band, both processed using the LaSRC on the Sentinel-2 images. And here on the right, we can see the same blue and red bands, but corrected using the Sen2cor processor. So considering the Sentinel-2 data, we can see that LaSRC correction wasn't as good as the Sen2cor correction, since those APU metrics were far away from the reference line. And we can see that the Sen2cor are more concentrated around it. So based on these observations, we believe that LaSRC produced more consistent images when applied to Landsat rather than on Sentinel-2 images, at least for the Brazilian territory. And this was expected since the development of LaSRC, which extends for Landsat Surface Reflectance Code, was focused specifically for Landsat 8. And we have noted that Sen2cor correction APU metrics outperformed the LaSRC correction on the Sentinel-2 images. And even though they presented uncertainty, and even though the reference used a different atmospheric correction model, Sen2cor performed best for Sentinel-2 images. And we intend to expand this work on the future by using Landsat Collection 2 data instead of Collection 1, since this can reduce errors, which can be from registration. And we intend to use more recent version of the atmospheric correction algorithms. So we intend to use LaSRC version 3 and Sen2cor version 2.9. And we also would like to enhance the images and see if other radiometric corrections, such as BRDF effects corrections, can improve these data, and also try different atmospheric correction algorithms. So we would like to thank aeronet investigators for the available data. We use it as a reference, the ESA for providing the Sentinel images, the USGS for providing the Landsat images, the ArcC team for hosting the code we use to generate the reference, and Fundo Amazonia for funding the project and this research. Thank you all.